So looking at number 7, we have a numerator of 2x plus 5, a denominator of x plus 1. Those are both completely factored, so there's no factoring that needs to occur, which means that we have no wholes. Right, coordinate of wholes would be none, because wholes come from factors that cancel from the numerator and denominator. Okay, then we would look for the coordinate of the 0 by setting the numerator 2x plus 5 equal to 0 and solving for x. So subtracting 5 from both sides, we get 2x equals negative 5. Then we would divide both sides by 2, and x equals negative 5 over 2. So the 0 would be at negative 5 over 2, comma 0. And that's negative 2.5, so we'd come over here to our graph, and along the x-axis at negative 2.5, we would plot our x-intercept. Okay, then the equation of the vertical asymptote, that comes from setting the denominator equal to 0 and solving for x. So we subtract 1 from both sides, and x equals negative 1 would be our vertical asymptote. So we'll come over here to the graph and sketch that vertical asymptote through x equals negative 1. Okay, then to find the coordinate of the y-intercept, we put zeros into the x's here. So y is equal to 2 times 0 plus 5, all divided by 0 plus 1, and that's equal to 5. So the coordinate of the y-intercept is at 0, 5. And we'll plot that with a closed circle on the y-axis. Okay, then to find the equation of a horizontal or oblique asymptote, since the exponents are the same, we use the ratio of the leading coefficients, which would be 2 over 1. So y equals 2 would be the horizontal asymptote. Okay, that was using our Bobo Batten Eats DC shortcut. If you don't like that shortcut, remember you can always do division to find the equation of your asymptote, either horizontal or oblique. So if I did negative 1 and then my coefficients 2 and 5 in synthetic division, I bring down the first term, there's a 2, multiply 2 times negative 1 is negative 2, add 5 plus negative 2 is 3, that's the remainder, which we discard, and then the 2 is the constant. And so that's another way you could get your y equals 2 as your horizontal asymptote. So we'll go ahead on the graph and put that dashed line through y equals 2. Okay, now we're going to look for some extra points on this graph to guide the direction that our curves are going to bend. So these x coordinates have been selected for us to make it a little easier, but you could always choose any x's that you want to on your graph. So if I put in a negative 4 for my x, then I have 2 times negative 4 plus 5 divided by negative 4 plus 1. So that's a negative 8 plus 5 is negative 3, and then negative 4 plus 1 is negative 3, and so that has a y value of 1. So we come over here, negative 4 up to 1, and then I can sketch my curve bending through those guide points and coming towards but not crossing the vertical and horizontal asymptotes. Then if we put in a 2, a positive 2 for the x, then we'll have 2 times 2 plus 5 divided by 2 plus 1. So that's 4 plus 5 is 9 divided by 3, which is 3. So we plot the point 2, 3 on the graph, and then we can go ahead and sketch the other piece of that hyperbola just like that. So now that we've got our sketch and our characteristics, we can identify the domain and range. So this domain is, since there are no holes, only broken here by this vertical asymptote at -1. So domain is negative infinity to -1 union -1 to positive infinity. The range, since there are no holes, we just have this one horizontal asymptote here at 2, is going from negative infinity to positive 2 union positive 2 to positive infinity.